The navigators on airplanes and ships often need to know the angle or bearing at which the plane or the ship must travel to stay on course, and they use the inverse trig functions to find such angles. In so doing, they also need to know the derivatives of the inverse trigonometric functions. Hi, my name is Tom Atwater, and that's what we'll be examining in today's lesson. Let's start with a theorem that establishes the conditions under which a function has an inverse. If f is differentiable at every point of an interval I, then df dx is never 0 on I. Then f has an inverse, and f inverse is differentiable at every point on the interval f of I. With these conditions in mind, we are ready to review the arcsine function and look at its derivative. So let's do that right now. The derivative of arcsine, which we can write as sine inverse of x, the derivative dy dx is equal to 1 over the square root of 1 minus x squared. For arctangent and its derivative, we have obviously y equals tan inverse of x, and then dy dx is equal to 1 over the quantity 1 plus x squared. Let's try an example. Let's look at and solve the derivative with of y with respect to x, the appropriate variable in this case, and y is equal to x times the inverse sine of x plus the square root of 1 minus x squared. So we'll apply our new formulas that we just looked at, and let me get to a screen where I have more room to write. And we'll start off by noticing that we must apply the product rule to this very first term. So y prime will be equal to x times the derivative of the inverse sine, which we just learned is 1 over the square root of 1 minus x squared. Then we have to add the second function, sine inverse of x, times the derivative of the first function, but the derivative of x is just 1. Then we need to take the derivative of this second term, and we need to write it as 1/2, and then we're going to write it as 1 minus x squared raised to the negative 1/2, but we have to apply the chain rule, and so that's going to be times negative 2x. Let's simplify this a little bit, and we can say that y prime is equal to, in this case we have x over the square root of 1 minus x squared. Then we have plus the sine inverse of x, and then at the end we have minus, because of the minus and the plus here, the 2's cancel, and we have x over the square root of 1 minus x squared. Well, look at that. We have the same functions, although this is the negative of it, which means they add up to 0, and we get that y prime is equal to the inverse sine of x. All right, so there's an example of using one of the derivatives of the trig function. Now, let's take a look at the derivative for arcsecant. The derivative of arcsecant is where we have y equals secant inverse of x, is equal to 1 over the absolute value of x times the square root of x squared minus 1. Once again, the best way to see this in action is to do an example. So let's take and find the derivative of y with respect to the appropriate variable, which in this case is t. And we have y equals secant inverse of 1 over t. So this is going to be equal to y prime is equal to 1 over the absolute value of 1 over t times the square root of 1 over t squared minus 1. But then we have to apply the chain rule. So that's going to be times negative 1 over t squared. We can work with this and manipulate it and simplify it. And one of the first things I want to say is that we we don't need the absolute values any further because we're going to be working with t being greater than 1. In other words, t is already positive, so we don't need that absolute value. And then we can simplify underneath here as well, and eventually we will get the following answer. Let me clean that up. And we will get the answer that y prime is equal to negative 1 over the square root of 1 minus t squared. And so it simplifies down to a much more reasonable simplification. So that's our y prime using the arc secant. Well, let's look at the derivatives for the other 3 inverse trig functions. We are looking here at inverse functions and inverse cofunction identities because they will help us to find the derivatives of these 3 inverse functions. In particular, let's look at cosine inverse first. Cosine inverse is equal to pi over 2 minus sine inverse, which means if we were to ask to find the derivative of cosine inverse, what we can say is, well, the derivative of this must be the derivative of that side, which the derivative of pi over 2, of course, is 0 because it's a constant. But then we could say that we would take negative the derivative of the inverse sine. So once again, the derivative of cosine inverse is going to be negative the derivative of sine inverse, which we already have the formula for. And similarly, if we want the derivative of cotan inverse, that's going to be equal to negative the derivative of tan inverse. And then finally, down below, if we wanted the derivative of cosecant inverse, then we can say that that's equal to the derivative, negative the derivative of secant inverse. So the 3 formulas we've already looked at, we can use and apply to finding the derivatives of these other 3 inverse trig functions. Let's take a look at an example. Let's say we are asked to find the derivative with respect to the appropriate variable, which in this case would be x, for the function y equals inverse tan of the square root of x squared minus 1 plus the inverse cosecant of x, where x is greater than 1. All right, so let's find the derivative for this particular function. So y prime will be equal to, well, we have the derivative of arctan, which you remember is 1 over 1 plus x squared, but this is our x squared, so what it would look like is 1 over 1 plus the square root of x squared minus 1, and that quantity is squared. But we have to apply the chain rule because this is an inside function. And so by the chain rule, we would say that we have to multiply this times 1/2 times x squared minus 1 raised to the negative 1/2. But again, we still have to use the chain rule once more because inside of the square root is x squared. So we would have to multiply that times 2x. And then we have to find the derivative of inverse cosecant. And remember that we just looked at the fact that this would be the negative of, or the derivative would be the negative of the derivative of secant. So that's going to be equal to negative 1 over the absolute value of x times the square root of x squared minus 1. Again, because we know that x is greater than 1, we don't have to worry about the absolute values anymore because it's redundant. When we simplify this, we will have that this y prime is equal to, here we have 1 over 1 plus, well, a square root squared just gives us x squared minus 1 for this first part. Then we can cancel out the 2's there, and that gives us x on the top, so I'm going to multiply times x, and then on the bottom, we're going to multiply times the x squared minus 1 inside of the square root. So that's the first part simplified. This other part we will leave as is at the moment, so it's going to be minus 1 over x times the square root of x squared minus 1. If we look at this, notice what's going to happen. The 1's will add up to 0. Then we can cancel this x with one of those x's, leaving us the x in the bottom. And what you're going to notice is that this term is now the same as that term, and we're subtracting them. So in this case, y prime works out to equal 0. Well, that was pretty great. But now it's time for you to try a problem. So let me bring it up and have you to a derivative of y with respect to the appropriate variable, which in this case is t, and you have that y is equal to cotangent inverse of t, of the square root of t minus 1. Pause the video while you work on this problem, and when you are finished, restart the video to check your solution. All right, recall that when we went over the derivative of cotan inverse, that's just negative the derivative of tangent inverse. So y prime is going to be equal to negative, and remember tangent is 1 over 1 plus x squared, so this is 1 over 1 plus the square root of t minus 1 quantity squared. But again, we have to use the chain rule because we have this function. And that means we have times 1/2 t minus 1 raised to the negative 1/2. And then inside that we have t, but the derivative of t is just equal to 1. So that's what we have. Let's simplify this. What we'll have is y prime equals, again, when you square a square root, you're just going to get this, and so the 1's are actually going to add up to 0, which leaves us with just a t in that denominator. So we have negative, well, and actually, yes, we'll have negative, and then we'll have a 1 up top. We have this 2 that is right here, so we'll have 2t, and then bringing this into the denominator is the square root of t minus 1. And that's the answer to the pause video problem that you just worked on. Great. So in this lesson, we learned about the derivatives of the 6 inverse trig functions. Be sure to work the exercises that your teacher assigns, and we'll see you next time.